So it may not seem like it yet, but there is a silver lining to higher hardware costs. Ideally, optimization. And so while hardware progress has slowed and prices have skyrocketed, we have seen RAM costs go up upwards of 4 times what they were prior. And even at that 4 times price, you're not going to see 4 times speed increase. With 128 gigabytes of DDR5 going as far as $3,400. And it's not just RAM. Even with the next GPUs, we're not seeing as massive of a raw performance uplift compared to prior gens. And this is just one example here from Gamers Nexus. Now, I encourage you to look at other benchmarks. This is just one very specific one. And obviously, there's also things to account, such as overclocking for these GPUs. But you can see here, the jump from 3080 to 4080 was pretty substantial, with an average FPS increase of over 40 in this benchmark, whereas we're seeing less and less with the 5080. And this is at 1440p, right, which is not necessarily a CPU bottlenecked resolution. If you run this at 1080p, it is kind of expected the difference would be small. And so a fairer comparison would be at 4K, but if we look at the 4K results, we're still seeing a pretty similar trend of a massive increase from the 3080 to the 4080 and a quite minor increase from the 4080 to the 5080. And so this is partially due to it using the same process node. And it's worth calling out, right? The rule of thumb for PC upgrades for pretty much as long as I personally can remember, 5 years. And so at that point, your existing hardware has really reached its end of life. Typically, the support limitations for hardware is anywhere from 5 to 7 years. 5 years, you're likely reaching that EOL. And also, worth noting, it's always been the most high potential for performance upgrades. So I did purchase a 780. Personally, I didn't find it worth it to upgrade until the 3080. And even to this day, I have not found a meaningful reason to upgrade over my 3080. Partially because I do not use local LLMs, and also I am somebody who games at a lower 1080p, 1440p resolution. And so it's not unheard of for newer generation GPUs to be minor in their improvements, but it's without a doubt with the current price increases we're seeing, it is now a right afforded to the enthusiast. To be a regular Joe would upgrade every 5 years or so. Now, to me, if you're doing this, you're probably an enthusiast. You have a lot of money to throw around. And it really is impossible to deny the negatives we face as consumers in today's AI-driven market. However, there is one positive that can come from this: better software optimization. Right? This is definitely an optimistic point of view. And I'm not the only one with this mindset. John Carmack here mentioning the reality of, hey, there is a lot of software out there that could run on outdated hardware if software optimization was truly a priority. I think we've all seen Doom running on pretty much everything, right? It runs on a toaster. I wouldn't be surprised if it runs on a Tamagotchi device. And Doom was made in a time where software optimization was essential. And he calls out specifically, hey, the market price signals on scarce compute would make it happen. And this is what I believe is happening today, right? It's so expensive to upgrade that, yeah, we do have hardware that's better that can do a lot of these things, but the person that actually buys our software can't afford it. And many of the major software advancements we got really were in that Doom era, right? The early 90s, when we were first transitioning into a 3D game space, they had to do a lot of clever tricks to make it work. Even when it came to things like texture mapping, at the time of Doom, there really was no standard. You could say that Doom's texture mapping used every trick in the book, except there really was no book at the time. Doom had to write it. And the result allowed the game to run at an unheard of speed of computers that were close to 100,000 times as powerful than top-shelf processors of today. Doom would not have been possible if they didn't focus so heavily on software optimization. There's one thing that is absolutely clear throughout history. When you put a stopgap, people will always find ways to get around them. Before the hardware shortage, the answer was always to throw more hardware at it. Worth's law describes this as being caused by rapidly growing hardware performance and customers' ignorance of features that are essential versus nice to have. Worth's law discusses this idea of software getting slower while hardware is getting faster. And it's attributed to Google. And the intent of the law is really to promote the idea of lean software, especially with vibe-coded apps. Vibe-coded engines are a really scary thing because we do not know how quickly these features that we're adding in stack up. You have one feature, you have another feature, another feature, another feature. Then all it takes is just a stack of features. The software might run fine after the first 10 features, and then 30 features down the line, you realize, oh, well, because of the neglection we put here, anything we introduced here caused it to perform worse. There's a graph here from Tech PowerUp that is kind of interesting for this. And we can see before, the realm of AI, the uplift was pretty freaking insane. It's like every time a new GPU came out, you were amazed by it. And so the jump from the 1060 to the 2060 was over 70% performance uplift. Whereas if you go from this 2060 all the way up to a 4060, you're really only looking at about a little over 45%. Now this image does point out that Moore's Law isn't dead. NVIDIA just wants to scam you all. I really don't think this is true. I don't think NVIDIA is truly scamming people. I think it's just when you've got the AI companies with their money bags coming at your door and saying, hey, we want 1 million GPUs, and you got the average consumer, obviously you're gonna take and focus on the companies that are buying up front like this. Not to mention with the current issue when it comes to the fabs, it's very expensive for NVIDIA to actually create these, and the rate that they can do it is much slower. Moore's Law really harps on the idea of nice to haves, and we're seeing a pullback of this even today. I'm sure you heard of the Unreal Engine 5 release and how many issues it's had with performance. Even titles that on the surface seem more stylistic rather than graphical, such as Oblivion Remastered and Black Myth Wukong. These are games that when you look at them, they don't look that graphically insane. And don't get me wrong, right? This is a pretty game, but when you look at it, it certainly doesn't make you go, wow. But if I look at something like Witcher 3, which came out many years prior, I can look at this and instantly see a game that looks much more visually impressive and runs 10 times better. No secret that Unreal Engine 5 had some issues when it first came out, but we are seeing with later revisions of Unreal, they have reduced the amount of bloat that is part of the engine. Fortnite recently, with the shift to Unreal, cut their shader counts by 68%, and this is something they're spearheading for the later releases of Unreal. And so they are making some changes to 5.8 to combat this. Now I will say Unreal Engine 5 inherently isn't badly optimized. It's really just bloated. A skilled developer with Unreal likely can make a pretty performant game with Unreal Engine 5. A lot of the issues we're seeing, these are cases where developers were a little bit careless with their development. You're given a timeline and you need to get something out quickly. It becomes a question of, doing it from the ground up versus just doing it from the middle up, where it's like, yeah, you're gonna have some bloat here that you don't need, but it's going to get you started and up and running a lot quicker. And so a lot of devs go with this path. With the claim here that, hey, software optimization should improve due to the cost of hardware, it's likely we're going to start seeing more dev teams, especially if they're focused on the cutting edge of graphics, focusing on a ground up approach. And this isn't just for video games, right? This is also something we're seeing on mobile. When a new phone is barely stretching the compute, and in some cases is even reducing it, we've seen with Google Pixel's 11 series, there is actually a reduction in the amount of RAM that's going into the device. And a lot of the marketing that they have for Pixel 11 is showing software-based improvements because they have to, right? They can't point at this and say, hey, this is a net positive for hardware. They need to point to things in the software space. So this year, Google is really focusing on the quality of life and software improvements of the device rather than the hardware improvement, which is totally reasonable, right? It's so damn expensive. Time will tell if these work well with a prior gen. Say they do introduce a lot of software optimizations into a shared OS like Pixel. The question is, hey, if this also benefits the prior gen, why do we need to upgrade? Hopefully in the case of mobile, that's not going to be an issue. Hopefully they're going to allow users to benefit even if they're on an older device. But I can totally see a world where they claim, hey, we have an accelerator, right? There's some specific device on the chip or in the hardware that's minor, but for whatever reason makes a major impact to their software. Hopefully we don't see that, but I think we might, right? Companies do have an incentive to fudge the hardware improvement. Even though it might be true some software releasing could run well on a prior gen, do not put it past these companies to make claims that their newer hardware has something in the secret sauce that allows for this to happen. But anyway, that's neither here nor there. And another interesting point here, newer phones are shipping with 144 hertz refresh rate. The ability to tolerate lower frame rates and noticeable jitter has gone down even for the most casual of user. Really, if you go back to maybe 2018 era, there really was arguments. And if you've been around the internet in that time, there was really the console wars. So you had console gamers and you had PC gamers. There were genuine arguments that, hey, it's 30 FPS is enough. And I would say once we hit to like maybe 2019 to 2022, this really started to go away. I think a lot of people got into PC gaming around this time. And so we did kind of start seeing a shift towards 60 FPS being the goal. A lot of console titles ship with 60 FPS. It is often a selling point in this time period. But now, we're, approaching past 2026, I feel like we're reaching an era where, yeah, 60 FPS is enough in most cases, but 144 hertz is still nice. Or to be technically correct, 120 FPS plus. Being able to actually see this on your screen has an impact, because if all of the devices you're using, your phone, your laptop, whatever, if all of them are operating on a 144 hertz display, your eyes are instantly going to be able to tell when you switch over to the smaller or lower refresh rate. Our eyes are really good about seeing this difference. Try to look at a 60 FPS game after playing a 140 plus FPS game, you instantly can feel that. And eventually you get used to it. But the point is, right, when every device we have is in this 144 hertz range, it becomes more and more annoying to readjust our standards every time we go down in frame rate. Again, I think you can get away with 30 and 60 in some cases, but this is getting less and less tolerable for the user, even casual users. So that's something to keep in mind. This is part of what incentivizes software improvements. We're also seeing changes in Android in general. Part of Android 17, they are going to have a stricter per app requirement on the amount of memory you're allowed to use. Question is, why didn't they do this before? Like, this is the kind of example where it's like, hey dude, they didn't have an incentive to do this before. And so now that they're putting some stopgaps on this, it's going to make developers think a little bit harder about the memory they're using. When they know that their app can actually be tripped due to excessive memory, they're more likely to put more time into preventing it instead of just haphazardly throwing it out onto the App Store. And there is an interesting part to this discussion, which is the realities of AI tools that we now have today. AI models are amazing, and they allow us, crazy speed and efficiency improvements, which allows devs to turn up features quickly, increasing risks of making the bloat soup even worse. With every new feature introduced, especially with AI, it really feels like a house of Jenga sometimes, where when you're building it up, everything's going great and smooth, and you take out bits and here and there, it adds up over time. And we haven't realized that yet, right? In the short term, vibe-coded engines look amazing. We've seen this with Opus 5, where it's producing these absolute cracked shooter games in one prompt. But you cannot deny here that there are trade-offs to this, and one of the biggest trade-offs being weight. There really is no weight to one-shotting a video game. You're not thinking about how is this going to be maintainable in the future. You're not thinking about how the systems play together. It's really just a haphazard introduction of code into your system. When it takes days to implement something, which that was a very typical thing, if not weeks really, pre-AI, developers tend to put more time into their decisions, right? You could waste days, if not weeks, making it play well with the rest of the system. Now that it takes just a few minutes to make it play well, you may not realize it until way down the line when you have 10 features introduced. And really, software optimizations are not something that can be easily fixed later down the line. It should be something that starts at the very beginning. With every feature you're adding in, if you're doing it really smart and you're making sure everything is isolated, sure, you can prevent this case. But the question then becomes, how do you identify where the bottleneck is? Every feature, every addition that you're making, if you do this really quickly, which is likely with AI, you're going to miss out on some of the nuances of how these play with each other, and you may not instantly be able to point which is a culprit. And oftentimes your AI tool is not going to be able to do that either. AI is a very good debugging tool, absolutely, but it is not magic. If you've ever debugged with AI tools, you know that it still takes a lot of triage back and forth. If you're at the state where, hey, you've got this massive stack of features and additions, and you're finding that there's maybe a memory leak issue or the FPS just isn't good, if you find out about this, odds are it's probably multiple parts of this that are causing it. So what ends up happening is you spend days and days, if not weeks and months, trying to reduce the weeds of this freaking yard of features that you've had added to your system. The irony of AI tools is that really this should help us with optimizations, right? This should give us power to think about optimizations at every level. But what we often find is that's the opposite of the case. I think there's probably ways to use AI that can benefit you from the optimization perspective. I think it's really just about slowing yourself down and to think about optimization yourself. Don't just assume the AI is taking this into account at every step, because oftentimes the AI is not doing that. AI is designed really to get you a correct result, not necessarily the best result. If you ask it and say, hey, I want to implement a feature, it'll get you to that feature, but that does not necessarily mean it was considering of things like performance. And it may not have actually thought about how it plays with the rest of the system. So this is an ironic part of AI, and really is a counter argument of, unfortunately, if you look at it as like a hardware cost pros and hardware cost cons, the pros of it is that, hey, more software optimizations. The con of hardware cost is that it's fueling AI. So this is kind of a counter to software optimizations in some ways, right? Not in all ways. I think there are ways to use AI that is beneficial to software optimization, but it depends on how you use it And I want to point out here, some devs will prioritize the path of obtaining complexity with optimization, which is hard to do. It's not something you can vibe code in a day. That takes a lot of thought and a lot of care versus just dumbing down the application. This is a possibility worth mentioning. Not all devs are going to follow this mindset. There are going to be devs out there, especially in the slop space. There's going to be some bad actors in those spaces that do not take the path of optimization. But I want to point out that the article is not aimed at this type of developer. We're assuming that you are a good actor here and our devs are good actors and they're not going to take the easy path at every step. That's the hope. Let's go into the counter arguments of software optimizations improving due to the hardware costs. Common argument I've seen is that, hey, if you look at the Steam survey, you'll see that there are users, majority of users, are using mobile GPUs or GTX 3060, 4060 type devices. And so the question is, hey, why are games not well optimized for those, even though that's been the majority? And really the problem with this argument is that it assumes that these are the avid gamers. It ignores the possibility that somebody owns a gaming laptop just to LARP. Not actually to LARP, but basically to say that, hey, they own the gaming laptop, it does not necessarily mean they're going to use it for gaming. Maybe they at one point wanted to. Maybe there was one very specific game they wanted to play. But it's fair to say that a lot of these users are not avid gamers and are not the ones actually purchasing these AAA titles. And so the question of, hey, why would it be any different, is because this isn't just affecting these users anymore. Enthusiasts are also affected by this hardware cost. These are the ones that are really the problem here. We're not worried about these low and middle. Really, it's the enthusiasts, the ones that are spending all the money. So to me, this argument really ignores reality. The majority of gaming laptop owners and even GPU owners are not avid gamers. On top of that, the new hardware prices are impacting more than the lower mid-tier. It's impacting the high enthusiast tier, aka the person still purchasing new game titles. And I think the point about AI tools being very prolific today is also partially a counter-argument to this. And I think it will impact us very heavily in the short term. I think a lot of devs are going to take the easy path. But I think as time goes on, this will change. There will always be an expectation of cutting-edge games. Right, I listed a few here, GTA, Assassin's Creed, Witcher. These are just examples. These are well-established games, and a lot of their marketing is based on visual. Imagine if the GTA trailer dropped and it looked just the same as the last game, or the Assassin's Creed trailer or the Witcher trailer. These games, their trailer comes out, people expect it's going to look better than the prior gen. And if it doesn't do that, the hype will die down a lot, pretty significantly. And that's not to say that that's the only marketing ploy here, right? I think if GTA's trailer came out and it looked hideous, people would probably still buy the game. But these games get that privilege, not all of them do. I think these games already have pretty privilege in that they have a story that people trust is going to be decent. They have, long history of success. But newer games don't get that privilege. And so they have a higher incentive to, actually enter into this cutting edge game position. Requires them to really optimize their game well and make sure that it can not only look good, but also perform decently, right? Nobody's going to play a 20 FPS game. And really, this cutting edge is constantly moving, right? If you looked at what looks good in 2020 versus what looks good in 2026, and it goes back every 5 to 10 years. Really, a lot of this is based on new console releases. So really, I think we can look at this as like, okay, Xbox One, or original Xbox, Xbox 360, so on and so forth. This is really what decides the eras. But, it is worth mentioning these counter-arguments. I think these are good counter-arguments to mention. Ultimately, to conclude, I think in the short term, the hardware shortage will feel like a negative, right? It's going to force a lot of companies to evaluate whether they've reached the true end of their optimizations. When they're in the boardroom discussing what they can do, it's no longer, oh, let's just up our system requirements, because now that's not really possible, right? They need to make sure that their high-paying user base can actually play the game. And so in the long run, and this isn't just for video games, this is for any type of software, the barrier of entry has gone up with the introduction of AI. And so you can no longer get away with just releasing a basic app. It needs to actually be pretty complex to even get your foot in the door these days. And with that comes bloat, and with that comes software issues that need to be made sure are optimized. And so in the long run, I believe the focus will shift to performance being a software-first problem. I think we've been spoiled by it being a hardware-first problem, and I think that time is over. I think shipping ambitious projects will rely on it. The bar being so high with AI, you need to release complex software, and with that comes software issues if not introduced early optimization tactics. But we'll see. I really hope that this is going to change software optimization for the better. I hope that we can look back at this time 10 years from now and say, hey, good thing we had this era because it gave us this technology or this optimization method, or who knows what could come about in this era of stopgap behavior with the hardware.